All right, today we're going to be learning about the spheres that surround the surface of the earth and make up the surface of the earth and what's above it, which is the atmosphere. So we're going to start by talking about prefixes. So prefixes are these beginnings of words that set a tone to what the word is going to mean. So like replace, restart, repost. Re means to do again. And the power of understanding what prefixes are really helps us to understand the English language and make sense of words that may not seem familiar, so we can at least pick the beginning of the words or the end of the words to help us make an understanding or an inference about what the word means. So this is a picture of the Earth from space. It's the first picture ever taken of the Earth from space, where you can see the entire Earth. And it's really made up of three major parts. There's land, right, which is rocks. There's water, right, which is our oceans and our lakes and our streams and our rivers. And then there is the atmosphere, which is the air above the Earth, which can hold the clouds, right, where planes fly. So there's really three major parts. But there's specific words that we give to them in earth science. So to start, hydro. So whenever you hear the prefix hydro, for the most part, it refers to water. And that's because water is made of hydrogen and oxygen, hydro, right? So like hydroponics is when you grow plants in water. Hydro, I can't think of another one. But point is, if you see the word hydro, it literally means water, all right? So next is litho. Litho means rock, all right? So a lith is like the Latin word for rock. And you could even like think about like megaliths. Megaliths is a reference to large rocks because mega means large, lith means rock, so it's large rock. And then there's tropo, which in Latin means, which in Greek means turning, all right? So if hydro is the water, right, or our oceans, litho is the rocks. That leaves us with one more thing, which is the atmosphere, which is tropo. But why would tropo be the term for turning? And it goes back to the fact that back in the day, there weren't large cities. So there wasn't light pollution in our atmosphere. So the ancient people, when they would look up in the sky, would see something that looks like this. Now, just so you know, this is a time lapse. And that just means that it is going to be showing us a span of multiple hours over just a few seconds. So this is a camera that's still on the Earth. You can see the horizon here a little bit. But we can see that the sky appears to be turning. Now, if you go to a place like in the middle of the desert or the top of a mountain where you're not near many cities, this is what the night sky looks like. There are that many stars that are visible to the human eye. And they used to think that the sky, was like a giant sheet that covered the earth in a way, right? And it just turned around the earth and the earth stood still. But we know that the sky is pretty much stationary relative to us. And we are on earth, which is turning, which makes the sky looks as if it turns. So the troposphere is the atmosphere, or at least the lowest part of the atmosphere. Okay? So let's take a look through, and I want to make this appear a little bit more real to you. So what are we looking at here? I see rocks. So this is the lithosphere. Rocks are the lithosphere. This is actually Mount Everest. But above it, around here where we see all these clouds in the sky, that is the troposphere. Okay, so the lithosphere are the rocks. Troposphere is the air above everything. What do we see here? Here's the moon. So this is from outer space. And this blue layer here is the troposphere and some of the stratosphere. Then you have like the mesosphere at the top and the thermosphere, which is pretty much space, nearly, like almost outer space, essentially. But this is the troposphere, this lower layer right there. What are we seeing here? The liquid is the hydrosphere, and the surface underneath is the lithosphere. So the lithosphere, really, there's always going to be some type of rock underneath our oceans, and that is the lithosphere. So the lithosphere wraps around the entire Earth. So let me show you this interesting picture. So this is North America, South America, which are the yellow parts, Europe here, Africa, and this is what's under the Atlantic Ocean. So it's not just this major like super flat area. If you went down, it would appear to be super flat, but it's way more complicated than that, and these are all rocks and sediments underneath our ocean, okay? If we took out all of the water from all of our oceans and we made a big sphere of it, it would only be this much water. So we like to think that we have a crazy amount of water on Earth, which compared to the size of us, we really do. But this is the amount of water that's in our oceans. This is the amount of water that would be frozen in our ice caps and in our glaciers at North and South Pole. And this little dot right there is all the fresh water that we can access. It makes up about less than 1% of the water on Earth. And that's all the water we can drink. So all humans are drinking out of like that tiny amount of water relative to the size of the Earth. All right, so now let's get into a little more earth science-based stuff. This is the reference table, page 1, and we're going to be focusing on 2 pages of the reference table for this activity. We're going to be focusing on this, which is the average chemical composition of Earth's crust, hydrosphere, and troposphere, and then we're going to look at an atmosphere map, which is really going to be called the temperature zones. All right, so let's break this down. First off, what does abundant mean? Abundant means a lot of or the most of. So if I have an abundant amount of money, that means I have a lot of money and I could spend it all. Unfortunately, that's not true, but I do have an abundant amount of knowledge in earth science. So let's break this down. We see crust here. Crust just means rock or lithosphere. We also have hydrosphere, which is made of water, H2O, and that is going to be our oceans and wherever we have water. And then we have the troposphere, which means like turning, which is what the sky appears to do. So this is going to be our lower atmosphere, the troposphere. So let's get into it. What do we have here? So with the crust, we have information about its mass or how much it weighs versus its volume, which is how large it is. So we have these elements that make up the crust. So most of the crust by mass and by volume, by size, is oxygen. Huh? Crust? Isn't crust made of rocks? Yes. Rocks are mostly made of oxygen on Earth, which is weird. And the other, like half of that is going to be this silicon. So silicon and oxygen make up this thing called quartz. And quartz is really the most abundant mineral on Earth's surface. And it's really like almost everywhere. Beaches, all sand, almost all sand is made of quartz, which is this stuff. So what is the most abundant element in Earth's crust by mass? That's going to be oxygen at 46%. What is the most abundant element in the Earth's crust by volume? That's going to be oxygen again at 94%. All right, so let's talk about the hydrosphere. Water is H2O, and if you really want to get specific, O1. So that means for every 1 oxygen in water, there are 2 hydrogens, which is why if you look at the percent of the hydrosphere is 66% hydrogen and 33% oxygen. 66 is double 33, meaning that there are 2 hydrogens for every 1 oxygen, which is why we have H2O. The other 1% is going to be made of other things that are like dissolved in water. So that would be like chlorine, sodium, calcium. These things are all dissolved in our oceans, and they actually are the things that coral reefs and shelled organisms make their shells out of. Finally is the troposphere. What do we breathe? Humans breathe in, What do we breathe? Humans breathe in oxygen. But you might be surprised that only 21% of our atmosphere is made of oxygen. So what are we breathing the most of? If we look, 78% of the atmosphere is made of nitrogen, at least the lower atmosphere, right? So 78% of the air that you're breathing in is nitrogen. Nitrogen doesn't really do anything for us when we breathe it in. It's just part of the air. Like, it's like not good or bad, but it's there. And we breathe it in. All right. So let's get into this now. This is a little more complicated. This is temperature zones. So there's a few major parts to this. There's going to be the altitude above sea level. And we have a chart for kilometers, and we have a chart for miles. One thing I want to point out is if a question asks you about kilometers, you might want to cover up the miles. So then you can see that the kilometers goes up by 10, 20, 30, 40. So don't look at the hash marks on the mile side if they ask you about kilometers. Cover it up. It'll make it a lot more clear. So then kilometers goes up by tens, and miles, I don't know if you can see it, miles goes up by fives. So this would be like 0, 5, 10, 15, 20, 25. And just so you know, sea level is really going to be where we are. So we are in the troposphere. This is where all weather happens. All rain occurs in the troposphere. And this is going to be high, really high. So if you want to understand how high a plane flies, planes fly just into the stratosphere. So right above this dotted line is where planes are going to fly because they want to fly above the weather. So let's break this down even further. So we have the temperature information. In the troposphere, at the surface of the Earth, or at sea level, right, the temperature is going to be on average 15 degrees Celsius. But if we go high above the Earth's surface, about 7 miles, or about 12, 13 kilometers, the temperature is negative 55 degrees Celsius. It's really, really cold up there. So the temperature decreases as we go through the troposphere, and then as we enter the stratosphere, then the temperature begins to increase, meaning that it goes from negative 55 at the bottom of the stratosphere to about 0 degrees Celsius. And then as we enter the mesosphere, it gets really, really cold. It goes from 0 degrees Celsius to negative 90 in the mesosphere. And then the thermosphere is called therm because that means temperature, where it gets super, super hot as we get really, really high into the atmosphere. About 75 miles above the Earth's surface, the temperature is nearly 100 degrees Celsius, which is really hot. Okay? So I suggest covering up different sections. Like if they ask you about the stratosphere's temperature, we're going to cover up all the other layers. We're going to say, okay, it goes up to the right, so that means the temperature increases as we go higher in the stratosphere. As elevation or as altitude increases, the temperature increases as well. So something else that we need to know is that the air pressure decreases as we go higher in the atmosphere. Remember, this is an indirect relationship, or I forgot what it was. Okay, anyway, here's our water vapor. Water vapor also decreases because all of weather occurs in the troposphere. So that means all of the water almost is in the troposphere. That's a lot of information. Hopefully that makes sense. Try out the Nearpod.